Okay, good morning class. So today we're looking at statistics. We're looking at examples 4. Exercise 30.1, which is on page 436. Right. So, with people we have dealt with histograms before. Okay? Histograms we drew in grade 8, 9, and 10. Okay? A histogram has been covered fairly extensively in earlier grades, exactly what I just said. They are a visual representation of group data and show the distribution and frequency of various intervals of any given set of data. Histograms are used to represent continuous numerical data. Give an example of continuous data. Height, weight, things like that. So things that can be, things that needs to be measured. Okay, it's normally a draw from a histogram, and whereas things that can be counted, it's going to be more a bar graph. However, if you now set up intervals for counting items, you also draw an histogram. Okay, when you have intervals basically. All right, so let's see what they say here. A histogram are used to represent continuous numerical data. However, they can also sometimes used if there's a large number of discrete data values. Exactly, this is what I said now. Okay, and particularly if the data is grouped. Horizontal axis has a continuous numerical scale. Okay, the one going across. The vertical axis shows the frequency, provided the data is grouped into intervals and equal widths. Example, the height in centimeters of 50 members of the 2010 Springbok squad were recorded. These measurements has been grouped in class intervals of 5 centimeters are given in the accompanying table. Okay, so they gave us this here. Close this. Okay. The question says, so if I must now draw this on a histogram, let's look at this on top. Then of course on your horizontal axis we'll have our people. Which page are we reading from? The president called twice.
President?
Yeah.
Ramaphosa?
Yes.
Yes.
The daughter from
Thank you.
okay. Examples on page 428. Okay. So what we have on our, put this right on top, is that on our vertical, horizontal asymptote we're going to have the heights. Okay, we are interval, height in centimeters. Okay, and then of course here we always have our frequency. Okay, so if you're going to go with 65, so how many classes you use? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we're going to do is we're now going to now put, unless the tools keep going to here. So 65, 165 to 170. So this is 165. Of course it's going to be 170, 175, 180, 185, 190, 195, 200. Okay, so that's not going to work, so I need to bring it over a bit. 195. That's not going to work. What's the name is going to be too cramped. So what I'm going to do is I'm going to rather make it in single units instead of using 2. So if this is 165, this is 170, 175, 180, 185, 190, 195. You see, this is a bit too small. 1 Otherwise, you're not going to see the what I want to highlight to you guys. Let's try again. Now the frequency we can hold. The frequency here. The interval, as you know, is going to go here. Okay. So I'm going to start with 165. 165, 170, 175, 180, 185, 190, 195, 200, 205, 210, 215. I think 215 is the highest. No, 210. So what we do is, just remember the values in between are the tens, okay? I don't want to write it in, otherwise it's going to be a bit cramped. Okay, so 165 to 170 is 1. So the highest here is 12. Okay, so if I make this 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. So that will work fast. Not so. You'll notice that I've not started against there. I could have if I wanted to. But just start away from it. Okay. What I'm going to do is I'm actually going to move this over 1 unit. Okay, there we go. So for 165 to 170 I have 1. So that is going to be 1. I'm just going to make it in green. 1. Then from 170 to 175 it's 2. Which is that thing. From 175 to 180 I got 11. It goes up here. Okay. Then I got 180 to 185, 10. Then I got 12. And then 9. Then 0, so it's blank. You don't have to write anything there. 4, the next one. 1. Okay. Let's do 210. What I do is I can shade if you want. The best part of maths, no, we can shade. Remind us of the home. The home primary school days. Right? And that's why they taught you to shade, so that you can shade in your histogram. Otherwise, I don't find the need to teach you how to color. No? You agree? I'm joking, no? I don't want no primary school activists coming here and. But people, you guys understand. Yeah. So from here we can see clearly that the tallest member of the squad was Andreas Becker at 208 centimeters. And the shortest was Annie Adams of 160. 168. Can you see that comes in this? Okay. They asked us to draw a histogram to represent a given set of data values. I just did that. Use your histogram to determine the modal class. People, what's the modal class? That has the most, and of course this one has the most here. No? And this one, of course, is. What is this? 185 to 190. Can you see that, people? Also, we can pick it up from here. You see that? So that's going to be B. Going to be 185. This 185 is less than or equal to H, which is less than 190. So yeah, is the equal sign right to 185. I erased 180 earlier on and I still write 180. Sorry. Right, you guys understand? Make mistakes easily in this section of work. Okay, it's easy, but the mistakes is easily made as well. Estimate. Now give an estimate of the mode. People, what's the mode? Number that occurs the most. Now the number that occurs the most falls in this, the class with the most falls in this category here. Not so? So when they ask us to give us a value of the mode, what's the name, value, and what I do is I can choose any value between 185 and 190. Not so? But we don't know if it lies more to the 185 or lean more to the 190. So what I'd say is, I just do a basic calculation. I say 185 plus 190 divided by 2, just to give the midpoint. Okay. So that gives us an answer. $185 plus 190 divided by 2 gives us 187.5. Does it follow the textbook? When they differ, then we can see why. Okay, we can explain why. Or maybe I'm wrong. Use your graph to determine how many members of the squad has a height of less than 185. Less than 185. So the values less than 185 are these values here. Not so. Which is 21, 22, 24. Not so. Otherwise you could have used the diagram as well. What was it? 185. And 185 comes here. Not so. So you just go. So it's going to be, I think this one, the first one was? This was 10. 11 is 21, 21, 22, 23, 24. You guys understand? So it's either by the table or the histogram. You can get the same answer. And the answer is 24. They ask usually graphs, so they wouldn't know if you don't make a mark anyway. So, in which interval does the median lie? People, they ask you the median. How do you calculate the median? The middle number of sorted data. So what we do is, we say, okay, at the end of this class I've considered 1 person. At the end of this class I've considered 3. At the end of this class I've considered 14, 24, 36, 45, 45, 49, 50. Can you see that, people? What is the half of 50? 25. So I'm looking at the 25th, 26th person. Not so. And then we know that from the 25th till the 36th person is in this category here. Can you see that? Including 25 and 26. So which class should the median lie in? 182, 185 to 190. 185 to 190. Alright, you guys understand? Is there any confusion? Nothing yet. Now when you look at the frequency polygon. Okay. I think in grade 10 did we speak about frequency polygon? No. Have you drawn a frequency polygon? No. Okay. Let us see, this is part of the same exercise. Yeah. So 13.1 deals with. It wasn't even that we turned the page, no? We're on the next page now. Sorry? Which page are we now on? 413. So frequency polygon. So now we are told that the frequency polygon are often used instead of histograms to represent data sets. particularly when we want to compare two or more sets of data or data. You see, if we're going to draw another histogram on here, it's not going to make it easy for us to draw conclusions from. You understand? So to draw another bulky graph on this thing, you won't be able to see the difference many times. Okay? So that is where the frequency polygon comes in, they say. So again, the frequency polygon is often used instead of histograms to represent data sets, particularly when you want to compare two or more sets of data. Exactly what I just said now. It is very easy to superimpose one frequency polygon upon another. So put on top of one another. Whereas it is not possible with a histogram. It is possible, but you won't be able to draw conclusions. As I said, it's going to be a lot of information and things you will be looking past. So it's going to be safer for you not to draw a histogram on another histogram using different colors. In example 1, we are told to use the same set of data given in the previous example to draw a frequency polygon. So how do I draw a frequency polygon? Okay, let me just pull it out here. Okay? Okay, so what happens is the frequency polygon is basic. Okay, what is a polygon? Geometric shape, yes. What else? What else do we know about the polygon? It's an enclosed figure, not so. It's made up of lines. Alright? So, if they ask us to draw a frequency polygon, what we do is we say, okay, we work out our midpoints of these classes, our class midpoint. Now, like we do when we calculate the mean. Okay. But anyway. So what we do is we work out the midpoint. So we say that we add 165. So there we already got 185 and 190. Gives us 187.5. This here it's going to be 165 plus 170 divided by 2. That's going to give you 167.5. And that's going to be 172.5, and then that's going to be 177.5, and then 182.5, and then 192.5, then 197.5, then 202.5, then 207.5. Not so. So that's the midpoint of these classes. So what I do is I say, okay, you take those midpoints. So let's take this off here. But what is the values here again? 165, 175, 185. 195, 205, 215. No? Right. So, of course, this is now the middle of these class intervals. Okay, this is the middle. So the first one comes in at 167.5. But remember, this is 170, 180, 190. 200, 205, no, 200, 210, 220. Okay. So the first one is 167.5. So 167, which is now the middle here. 0.5, so this is the 1. The next one is 2. The next one is 11. And then 10. And then 12. And then 9. And then sorry? 0. And then 4. And then 1. And then no, that's it. So what happens is now you take a ruler and you join these dots. Okay. So you start here. There we go. You mustn't have an arrow, no? This one now look for the line of now arrow. There we go. That's your frequency polygon. So what they do is they connect this to the empty class before, there, which is there, and then the empty class after. So what do you notice? It's a figure. Sorry? Oh, I missed one. Thank you. Yeah. I must touch you. That was part of the grounded. So what do you notice? It's made, this geometric shape is made up of straight lines only, and there's the closure of it. Can you see that, people? Easy, no? Right. Sometimes you don't even have to close it, so we leave it open for now, because the textbook didn't close it. Okay? So that's your frequency polygon. Then the question says, you see, okay, they did close it. Let us close it as well. Okay. As I said, you just have one empty space before and one empty space after. You just connect it according to the width as we did before. Okay. So this is what the computer drew, the author. Frequency polygon of heights distributed of 2010 Springbok squad. And there's exactly what we drew now. Not so? Take a shot. What? Beautiful. Yeah. Let's look at example 2. Example 2, we are told, are we still on the same page? 130. They want to be moved. Page 151. So here we are told that the foot lengths of 35 boys and 35 girls in grade 11 group of learners were measured in centimeters. Okay. This is on page 130? 431, same page. Huh? Yes, okay. So the foot length of 35 boys and 35 girls in grade 11 group of learners were measured in centimeters. The measurements were grouped in 2 intervals, 2 centimeters, and recorded intervals of 2 centimeters and recorded in the given table. Right, so what do I need? Draw a histogram to illustrate the foot lengths of the boys. So what do I need? I need a graph. Okay. Alright, so in example 2, how many tons? A bit better. Okay. Okay, so example 2. So the lowest is 22. Okay, so the question was to draw a histogram. Okay. So for boys, it's 22 to 32. So it's 10. So it's 22, 24, 26, 28, 30, 32. So you see all this unnecessary space here. So what I do is I make it rather a bit bigger. So I go 22, right, so let's go again. We got 22, 24, 26, 28, 30, 32, 34. Now, okay. So let's go to the first one. And so you got your frequency here. The highest number is 14. Where's 14? Yeah. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. We always try and make it as big as possible. So then we'll give you the best reading. Okay. So, you will be able to draw a conclusion better like that. Okay, so this of course is the height of the lens, no? In centimeters, I think. Yeah, centimeters. Okay. Important to write the names of the bars. Okay. So let's go with the first. In the first case, what do we have? In the first category, we have 1. So there's 1. And then 5. And then 10. And then 12. And then 7. And then that's it. That's all. So that is the histogram for both. That is A. Let's look at the B part of the question. B says, on the same grid, draw a frequency polygon to show the distribution of the foot lengths of boys. Now, people, we don't have to, as we did in the previous sum, work out the midpoints. Did we use the midpoints here? Did we use it here? No. We just use the middle. Not so. So now in future, you're not going to see me do the calculation for that. The only time you'll see me work out the midpoints if I want to work out the average, the mean. Then I would tend to work that out because I need it in my calculation. Okay, so B on the same grid, draw a frequency polygon. So what do I do is, I connect the midpoints. So this is a midpoint here, not so. Whoops. The midpoint from there to there. Again, now you don't need the arrow there, no? This is onto the midpoints. The class before and the class after. So there's your frequency polygon. You guys understand? Okay. Then C. On a separate grid, draw 2 frequency polygons, one showing the distribution of the foot lengths of the boys and the other the distribution of the foot lengths of the girls. Okay. You guys probably know I'm going to use the same thing, no? So the boys is already on here. Okay. Should be able to pick it up. Strange. It allows me to pick it up now. But anyway. So there we have that for the boys. No? So let's use a different key for the girls. Of course, we're not going to use the same key. Alright. So what I'm going to do is I'm just going to put dots out so that I know exactly where I must place the lines. So 22 to 24 is 6. 6 is there. No? Why at that point? Because I'm going to draw a frequency polygon. Okay, I'm not drawing a histogram. I don't need the histogram. No? I just estimate and I work. So the next one is 14. So it's 10, 11, 12, 13, 14. 14, yeah? And then 10. So you can see the same value, so that is the same length. And then 4. And then 1. And then nothing. Okay. What I do is I now go with that line, pink, pick this up here. So now we go. Connect there. There.
So,
Yes?
14 on top, what is it?
Well, I picked Mr. 14. Okay. Okay. Okay, can you see the difference there, people? Okay, so many things you can see. You can see that the graph is more leaning to the side. The bulk of the information or the mode is more to the side here. Even the average will be above the side. Can you see that, people? And that is the reason why we use a frequency polygon. So it's easy to superimpose, to put two graphs on one. Okay? Zara, look, see ouens van nou, man. Leave the guys, whoever you're talking to on the phone, so look here a little bit, okay? Right. Then this boring. Yes, it is. Okay, I agree, but oh, you didn't say. You know, this is not much of a challenge to you. That's why you don't want to look here. Okay, but anyway, D. Oops. Alright, so here we are now told in which class or which interval do boys and girls have the same frequency foot length. Ah, we spoke about it. 26 and 28. E. Give the modal class interval for both boys and girls. The modal class is the class with the most. So the boys, the modal class here is 28 to 30, and the girls is 24 to 26. Otherwise, you're going to pick it up here as well from the graph. Not so. Right, for homework, I would like you guys to do exercise 13.1. We will conclude the examples in our next lesson. Enjoy the rest of your day. Good morning, class. 13.1. The full lesson can be found in the description box below.